This video is part of my Udemy courses. See the description for more info. Hey there, in this lecture we are going to explore variables and function returns. Let's first focus on variables, what they are, and how they are used. A variable is simply a container that is used to store a value. I'm going to explain what they are with a small example. Let's say you want the movement speed of your player to be 5. So in your code, you enter 5 wherever you need to specify the speed of the player. So this works and your player moves at a speed of 5. But think about this for a second. What if you want to change the speed? What if you want to make it faster and so you think that a speed of 6 would work better? In that case, you're gonna have to go around and change every mention of 5 to 6, and that will work, but of course it's gonna take a lot of time to change. This is where making use of variables will help. You can create a variable called moveSpeed and set its value to be equal to 5. This is simply how you create a variable. Now whenever you need to specify the speed in your code, you can simply enter moveSpeed, and so when the computer reads your code, it's gonna see 5. So you have indirectly entered the value 5 through the variable. And now the main benefit of this is that you can change the value of moveSpeed to 6 or 10 or any other value, and you don't have to make any other changes anywhere else. Let's say you make it equal to 15. From that point, it's gonna be 15 everywhere else. So instead of 5, the computer is gonna see moveSpeed as 15. This is why variables are used, because numbers and values are very important in programming, and using a variable, you can give a name to a value and change it whenever you want, which makes programming much easier. Now let's go into our project so we can play around with variables. For the first variables example, I'm gonna create a new object. I'll simply name this variables, and I'll go ahead and place it in the room. We are not going to do much with this object. We will be returning true or my object after I show you a basic example of variables. Let's go into the object properties and add a new event, which will be create. Here I'll create a variable called a and set it to be equal to 5. So we have created our first variable. Now I'll create another one. I'll call this b with a value of 3. So now we know how to create variables and we can use them to do some math. Let's say we wanna do 5 plus 3, so that's gonna be 8. Instead of using the actual values, we can use our variables a and b. Here I'll create an expression that adds a and b together. This part is called an expression, which basically means that it's gonna result in a different value. So it's simply gonna add a and b together and give us the result. Now we can store the results of this expression in another variable. So I'll create a variable called results, and this will store the results of our expression. Let's check the value of this result variable by using the showMessage function. This basically shows a message to the user by opening a pop-up window, and it should only be used for testing like we are doing right now. This function takes one argument, which is the value that will be shown, so let's pass in the result variable. Now I'll run the game, and after it's done compiling, you're gonna see this pop up with your result value. We see 8 here because that is the result of a plus b, which adds 5 and 3 together. Similarly, you can use other operators such as minus, multiply, and divide. As an example, I'll multiply these values together, which should result in 15 since we are multiplying 5 with 3, and when you run the game, that's the value you're gonna see. Now you can also skip using a result variable and use your expression in the function argument directly. This will also work the same way, but you will need to use a variable if you want to use this value in multiple places. We are not going to use this object now, So I'll go in the room and delete its instance. Now let's go back into all my objects. Here we're gonna use a variable to control the height of the halo above our instances. So let's go into the create event and here create a new variable called halo height. The default value for this will be 0. Now we are creating our variable in the create event because it runs only once and it's the first event to run in an instance. That makes it the perfect place to initialize your variables. Initialization simply refers to creating a variable and giving it an initial value. We are gonna use this halo height variable in our code in the draw event. Here I'm subtracting 60 from the y position of our halo, so that is currently the height of the halo since it's 60 pixels above the instance. Now I'm gonna replace this 60 value with our new variable halo height, and you know that it's equal to 0, so right now the halo is not gonna have any height. If you run the game, that's what you'll see, the halo at the center of the instance. So of course you can change the height by changing the variable's value in the create event, but we are gonna do something different. We are gonna change the value every frame so that you see a moving halo. For that I'm gonna go in the step events and here increase the value of the halo height variable by doing this. You'll notice that in this statement we have a plus sign before the equal sign. This means that the variable on the left will increase by the value on the right. So if it's 1, it'll become 2, if it's 8, it'll become 9, and so on. And because we are in the step event, the value will go up by 1 every frame. Before we run the game, let me go in the room editor and just rearrange these instances for a better look. Now I'll run the game and you can see a moving halo. Its height is increasing by 1 every frame, but of course we can't see the actual value of the variable, so we are gonna draw that now. I'll go back into the object in the draw event. Here we are gonna call the draw text function, which simply draws some text. The first two arguments here are the x and the y, where the text will be drawn. So for these I'll enter x plus 40 for the x and y minus 30 for the y. This is simply where I'm drawing my text, so it's gonna be to the right of the instance and a little above it. Now the third argument is the text that needs to be drawn, so I'm gonna pass in the halo height variable, so the value of the variable will be drawn using this function. Let's run the game, and now you can see the exact value of the halo height and how it keeps increasing. In the step event, instead of increasing it by 1, you can increase it by 5, and so it's gonna go up much faster. You'll see its effect in the game as the halo shoots into the sky. You can make it slower by using a small value such as 0.1. You can also make it go down by using the minus sign, so the halo will go in the opposite direction. Now there is a different kind of statement that you can use to increase or decrease a variable by 1. So instead of doing this, you can just use two plus signs, so the halo height will simply go up by 1. There is a similar statement for subtraction. You can use two minus signs to make the variable go down by 1. Now we're gonna look at function returns. Basically, when you use a function, it can return a value. That value can be stored in a variable. For my example, I'm first gonna delete this statement and here call the getTimer function. This function simply gets the time that has passed since the game was started. The value that it returns can be stored in a variable, and I'll store it in the halo height variable. So the function will be called, it will return the time that has passed, and that will be stored in halo height. Now since we are in the step event, this value will keep changing as more time passes. I'll run the game now and you can see that the halo isn't anywhere to be seen. The halo height, as you can see here, is very high because the getTimer function gets the time in microseconds. That's why it's so large. I'm gonna go back in the step event and divide the time by 100,000. This way it'll be much smaller. So now I'll run the game and you can see that the halo height is increasing but at a much slower rate. You know that we are not adding anything to the variable, but we are simply using a function to return a value. So this is also something that functions can do, and we are going to use this feature a lot. Now I'm going to remove this function call. Instead, I'm going to use a different function that simply gets a random number. This function is called random and it takes only one argument. This argument is the maximum value that can be returned. So for example, if I enter 50 here, then the function will return a value between 0 and 50. It's gonna return a random value every time it is called, which means that it'll be different every frame. So I'll run the game and we see that the halo is moving frantically because of the random function. Every frame it gets a different height, which is why we see this result. This function simply takes an argument and depending on the argument, it returns a value. You're gonna be seeing a lot more functions like this as you learn more about GML. Now variables can also hold values that are not numbers, so we are gonna look at the different types of variables in the next lecture. Hi there, in this lecture we are going to look at the data types that can be used to create a variable in GML. A data type basically tells what kind of data is stored in a variable. First of all, we have numbers, which is what we used in the previous lecture. A number data type is called a real in GameMaker. So a real can be any integer value or it can be any decimal value. Another data type is a string. This is simply some text that can be stored within double quotes. So you can create a variable that stores some text. It could be the name of the player or the name of an item or anything that has to be stored as text. A string variable can be used in the drawText function, for example, to draw the text string to the screen. To demonstrate this, I'm going to go into our GameMaker project and go into the create event of OhMyObject. Here I'm going to create a variable called hideText. This will be a string, so I'm gonna put the double quotes and inside the quotes I'm gonna write this. This simply says height followed by a colon and then a space because then we want to follow it with the height value itself. Now to implement that, I'll go in the draw event into this drawText function where we are already drawing the height value. As you can see in the list of arguments at the bottom, this function here requires a string in the last argument, but the variable that we are passing in is actually a real because it stores a number, it's not a string. So the way it works is that because this is just one real value, it's automatically converted into a string. So what we want to do now is to draw the height text before this number value. For that, I'm gonna put the height text variable here and then use the plus sign to add these two together. Now let's run the game and see what happens. And as you can see, we are getting an error. This is a do add error, which means that it was unable to add the two values together. Now why did that happen? Well, that happens because the first value here is a string and the second value is a real. So these are different data types and you cannot add them together. Since the drawText function requires a string, we want this expression to result in a string, so we are going to convert the real into a string. To do that, I'll use the string function and pass in the halo height as the argument. So what this does is that it takes a real as the argument and converts that into a string. So now this expression results in a string. And since both of these are now strings, they can be added together. And now the function should draw the complete text with the height text and the halo height itself. Now let's run the game and on our instances, you can see the height text along with the height value itself. So this is basically how a string can be created and how it can be used. And of course, you can change the string to say whatever you want. Now I am going to go in the step event and remove this random function. Instead, I'll make the variable go up by 0.1 so it looks better going forward. Now let's talk about a Boolean, which is a simple data type that can have only two possible values. Those values are true and false, which are equivalent to 1 and 0. So this can be used, for example, to tell whether something is enabled or disabled, or whether some condition is true or false. So back in the create event, let's create a variable called drawHaloHeight and set it to true. We're going to use this Boolean variable to check whether the halo height should be drawn or not. So if this is set to true, we should draw it, but if it's set to false, then we should not draw it. Of course, it won't do that by itself. We have to tell the code to do that, which we are going to do in a later lecture when we are talking about conditions. Now there is something small but very useful that you should know about. When you start a line with two forward slashes, that creates a comment. This is just a piece of text that is not a part of the code, but is simply there, maybe as a title or to explain what the code does. So a comment doesn't affect the code or the game itself, but is simply there for anyone who is reading the code, which may be you or someone else. We are going to use this feature going forward to help organize the code that we write. So these are the three data types that you'll mostly be working with in GML. There are more and we're going to learn about them as the course progresses. Now these variables are instance variables since they exist within an object's instance. There are other kinds of variables as well, such as local variables and global variables, and we're going to look at them in the next lecture. Hey there, in this lecture we're going to learn about variable scopes. The scope of a variable tells where that variable can be used. The variables that we have been using are called instance variables. These variables are created in objects, and when the game is running, they are only available in the instances of that object. So each instance has its own set of variables that were defined in that object. To demonstrate how instance variables work, I'll go into our project and then go into the room editor. Here I'll drop an instance of OShip. This is our second object, which doesn't have the variables that were defined in the first object. To demonstrate that, I'll go into the OShip object, and in the events window, I'll add a new event, which will be step. Here I'm gonna try and increase the value of the halo height variable. Now this is not going to work because OShip doesn't have that variable. It was defined in OMyObject. So I'll run the game, and here we have an error. This says that the variable OShip.haloHeight is not set before reading it. OShip is the object and HaloHeight is the variable. So this error simply means that the variable does not exist for that object. I'll click on abort to close this error. So this demonstrates how instance variables are unique to each instance. They are not available to other instances but only to them. Now you can create global variables, and any global variables will be available to all instances of all objects. So any instance can read that variable and even change its value. To create a global variable, you simply start the variable name with global followed by a dot and then the variable name. Let's go into OMyObjects, and in the create event, we are going to convert the halo height variable into a global variable. So to do that, I'm gonna start it with global and then a dot. So this is now a global variable. Now you do need to type global every time you want to use this variable. So I'll go in the draw events, and wherever the variable is mentioned, I'll start it with global and then a dot, because now it's not available as an instance variable anymore. It's also being changed here in the step event, but for this example, I'll simply remove this line. Now since the halo height variable is global, you should be able to access it in instances of other objects. So I'll go into OShip, And here in the step event, make this variable reference global. Now I'll run the game, and first of all, you can see that we don't get an error anymore because the variable is now global and accessible. You can also see that the halo height is increasing, and it's increasing for every instance. That's because we are now using a global variable for this, and it's the same for every instance, and any instance is able to access it. This kind of a variable is usually used to store global data that every object should be able to access. So that could be the health of the player, their score, the player's name, and so on. Now we also have local variables. These are variables that are only available in one event. So let's say you create a local variable in the step event. You will only be able to use that variable within that step event, and after the event is finished, the variable will be deleted. To create a local variable, you need to use the var keyword. So for example, I can make this height text variable local to the create events by entering var before it. You don't need a dot here, only a space. Now this variable has turned yellow, which means that it's a local variable. It'll only be available within this create event, and after the event ends, the variable will be deleted. So since we are reading the variable in the draw events here, it will now throw an error because it's not available in this event. I'll run the game, and there we have an error. This states that the height text variable is not set. That's because we made it a local variable and it's only available in that create event. Now I'll turn it back into a regular instance variable. Now one practical use of local variables is to store values temporarily. So in the draw event, you have these offsets here, and you can store them in local variables instead if you want to use the same values in multiple functions. I'll do that. And now we can simply add these offsets to the x and y values in the function. Local variables are perfect for this because after this event, we don't need these offsets anywhere else. When you run the game, you will see the same effect. The text is drawn in the same position, but the way we have written our code has changed. So to recap, the three main variable scopes in GML are global, instance, and local. Global variables are available to all instances. Instance variables are only available to the instances that have them, and local variables are only available in a single event. We will of course get used to using these different kinds of variables as we use GML more. Now in the next lecture, we're going to learn about conditions, which are gonna give us much more power in GML. So I'll see you there. I hope you enjoyed the video. You can watch more tutorials from here and make sure to subscribe for more GameMaker content. I'll see you in the next video.